Morning, guys.
Morning.
All right, guys, starting with number one. This is a power rule problem. But to do power rule, we have to clean up some things, right? So a couple of things that we see here. Expansion, we have to take care of those parentheses squared. We got to take care of the radical, and that denominator has to come up. So we got to do all three things before we can consider power rule. Okay. So as you clean up, you're still going to hold on to your integral and dx notation. It's only after you apply power rule, then these notations drop out. But as you're cleaning up, make sure you keep your integral and dx notation. Going to FOIL out that 3 minus x ahead of time. Okay, square root of x to the 7th. What is that as a rational exponent? X to what power?
-1/7.
Careful with this, though. It looks like 1/7 because it looks like there's a 1 here, but there's actually not a 1 here. What number is that?
Oh, it's good.
2. So is it 2/7?
Yeah.
Close. 7/2. So a lot of students, they either say 1/7 or 2/7, but it's actually 7/2. But I'll leave it in the denominator for now, but they will come up. Yeah, I put that there because this is a one that is easy to miss. Continuing to clean this up. Sorry, mine plus 12x, not 12x squared. Okay, power rule for each term. Looks like everything is ready, right? My parentheses are resolved. Radical taken care of. Denominator bottom to the top. So now I can do power rule for each term. As soon as I apply power rule, my notations and at the ends here can drop out. Okay. Every degree rises by 1. A constant is going to turn into a degree 1, x to the first power. -7/2. I can add 1 to the exponent, so really it's plus 2 over 2. So that gives me a new exponent of -5/2 divided by -5/2. Now E is a constant, just like 18. So that becomes EX and then plus C. Right, so that's our answer, but we can do a little bit of cleanup with some of these coefficients here. So this is really -2/5 times 5. Right, so -2/5 times 5 becomes -2, because we're -10/5, which is -2. And I can also push that denominator or that variable back down to the denominator. Okay, any questions? Okay, number 2, same thing, also power rule, but with that fraction, that denominator, we're going to have to eventually split up into individual fractions, and then we're going to bring them up individually. But this is also a power rule problem, but just like before, we do need to do some significant cleanup before we can apply a power rule. Okay, questions so far? Now, we have to figure out what comes up to the top. So for each of these terms, what comes up to the top? Good. But what stays below? Yeah, so the coefficient. So the coefficient does not come up, just the variables. Okay, just the variables. Okay. So I'm just going to clean up as I go along with that with my coefficients here. If I can reduce, I'm going to reduce. Right. So we can find common denominators and subtract. This is 1 minus 1/2, or we can think of it as 1/2, right? 1 minus 1/2 is 1/2. So all this time, no calculus yet. So that's why all these notations are still in place. 1/3 minus 1/2, I can think of it as common denominator of 2/6 minus 3/6. Right? Common denominator 6. Balance my fraction here. 2/6, same thing as 1/3. 3/6, same thing as 1/2. 2/6 minus 3/6 is negative 1/6. Five minus 1/2, that's the same thing as 10/2 minus 1/2, which is 9/2. All right, so now all that work is just to get these terms nice and ready for power rule. All right, so everything up to this point is just algebraic cleanup. Okay, now we're ready for power rule. Now that I'm going to apply power rule, I can drop these integral notations and dx notations. Add 1 to the exponent. 1/2 plus 2/2 is 3/2. Negative 1/6 plus 6/6 is 5/6. Nine halves plus 2 halves is 11 halves. So this is my calculus step, and this is the only calculus step in the problem. After this, I'm just cleaning up. Okay, any questions here? Okay, I'm going to flip all those denominators up to the top. Three halves becomes 2/3. 5/6, the same thing as 6/5 up top. 11 halves in the denominator, same thing as 2/11 up top. Okay, 10/12, which I can reduce to be 5/6. Two over 44, same thing as 1/22. There's no exponents to move down because these are all positive exponents. We can keep them where they are. There's my answer. Okay, any questions here? Okay, number 3. These are all antiderivative integral rules, but we talked about how on your quiz, I would like for you to just memorize and build out your derivative rules, right? Because here, if these are derivative rules that we learned first semester, we know that if we're just reading this column here from right to left, we have all the integral rules in front of us, right? Antiderivative cosine is sine, secant squared becomes tangent, secant tangent becomes secant. So really, we just have to rely on this to help find all of our integral rules. So integral of secant tangent is what? Yeah, just secant, right? Now the 5 is going to stay, so cosine becomes sine. So this negative is still going to stay there. Cosecant squared becomes but the negative has to go somewhere, so it has to come along with that, right? So cosec, because negative cosecant squared is cotangent, cosecant squared must be a negative cotangent. And then sine x becomes what? Good. The negative has to go somewhere, so it has to go with a cosine, negative cosine, -6. Each of these, they do produce their own plus c's, but we can just kind of gather all that together and just put plus c once. Okay, number 4. Use 3 midpoint rectangles to approximate the area. So we have to go through our width formula. Okay, build from scratch. Okay, so first step is let's build our width. Sorry, what's our n value? 3. Okay. Okay, so let's build our subintervals here. So we know we're gonna where are we gonna start? What's our left endpoint? -1. So -1. I'm gonna keep adding 2/3 until I hopefully reach 1. So -1 plus 2/3, same thing as -3/3 plus 2/3. Okay, keep going, plus 2/3. Plus 2/3. 1. Okay. Now, these points will be perfectly fine if we want to use 3 left-handed rectangles or 3 right-handed rectangles, but we got to go further because we're asking for midpoint rectangles. So I have to go and find the midpoint between each of these subintervals because these are the values I'm going to be inserting into the graph to get their respective heights. So the way I find the midpoint between two numbers is I just find the average, right? If I find the average, it's just the 2 endpoints divided by 2. So -1 minus 1/3 over 2 is the same thing as -3/3 minus 1/3 times 1/2, right? I can just think of it as half of my endpoints added together. So -4/3. Sorry, -4/6, which is -2/3. Between -1/3 and 1/3, if I add those together, I get 0. 0 times 1/2 is still 0. 1/3 plus 3/3 is 4/3. 4/3 times 1/2 is 2/3. Okay, everybody good with being able to find those midpoints? Okay. All right, so now I'm going to go through my area formula. Area of a rectangle is width times height. Every width is 2/3, and the heights are going to come from these 3 midpoints. Hand out there if you want to get that. So width is 2/3. The height of my first rectangle is f of -2/3. Now I'm writing the width each time, but you could easily just factor it out if you like. And now we have exactly very direct notes as to how to find those heights. We're just going to take these x values, insert into the function, and that will give us our y value. And then we can just add up all those decimals. Going to factor 2/3 out. So insert negative 2/3 into the function. Okay, f of 0 should be easy. 4 minus 0, just 4. F of 2/3. Okay, any questions with any of the steps? Okay, number 5, use limit definition. So I will give you a formula sheet where you can pick off that information. So limit as n approaches infinity, width is b minus a over n, left endpoint is a, so a plus width times I. Okay, so we start off by finding our b minus a over n. This time we're not going to replace n with anything because we're going to push n out to infinity. Let's make our substitutions. Okay, everybody good so far? All right, so we have to get this out of function notation. We do want to multiply the width and height together, but this f is not quite set up for us to, they're not quite compatible. So I have to use my function expression to get it out of function notation. So stepping off to the side, here's my function. Create a space for our argument. Every x I see, I'm going to remove it and provide a reserve space for my argument. Okay, so now I know what to put in place of this high component here. Replace it with this piece here. So now it's just a bunch of algebraic steps, try to get all this cleaned up. Okay. Three minus two is one. Okay, distribute through the width component now. Give each term its own summation. Right, push out each of the coefficients that we can so we can clearly see the rule that we want to take advantage of here. Summation one, summation I squared. Here we know we can just pick off the most important information here, the 16, the n, and the 2n. Everything else is going to be a lower degree that we don't really, that's not going to really impact us. 16 times 2 is 32, and then we have 3n cubed here, so okay, so we pick off each of the coefficients here. Degrees are matching, so it's 2 over 1, 16 over 2, minus 32 over 6.
So are you gonna give us the summation formula?
Yeah, so I'll give this information to you. This will be your formula sheet. Okay, I won't give you the trapezoid area, but these I will give you. Okay. Any questions with 5? Okay, number 6. Okay, find f of x given f double prime. So we just have to take the antiderivative twice, and each time along the way, a plus t or plus constant will show up. So let's show all the notations that go along with this. We know that to get from f double prime to f prime, I need to take the antiderivative. So I just want to produce the notation to indicate what I'm about to do. Once I provide a notation, then I'm going to take the steps necessary to resolve that. So there's still f prime, but now I can resolve it using power rule. So what that means now is I'm halfway there. I can keep going, find f of x, but to find f of x, I need to take the antiderivative of my f prime. So I'm just going to set myself up for that. I'm just also cleaning up the coefficient as I go along. So once I resolve this, then I'm able to take this expression and make it rise up to the f of x level. Keep the coefficients. Add 1 to the exponent. Keep the coefficient. Add 1 to the exponent. Okay, what does c become? Cx, right? That's a constant. Imagine that's a 3 or 5 or 8. 8 will become 8x. C will become cx. However, this will produce its own what? C. So you can say plus k or plus c sub 2. Either way is fine. Those are the most common ones. All right, so there's your answer. We can do a little bit of cleanup though, clean up all the coefficients, and we are able to rise up all the way from f double prime to f of x. Okay, some things I didn't get to in this review, the Riemann sums, the table of values. I just decided to take care of the ones that I feel are more involved, and we can do some of those in class today. All right, any questions? All right.